a very quick revision on particle model, GCSE exam physics paper. So let's just get started. The first thing that you need to know about this is the particle models of solid, liquid, and gases. What you need to know for your exam is the distance between the particles. So first, for the solids, very close or compact, closely packed. That's the keyword you're looking for. Then the second thing, you need to talk about the force between the particles. Obviously the molecules of the solid will have more stronger force between them, that's why they cannot move apart. So strong force of attraction. The third point you need to tell about is the motion of the particles, motion of the molecules. So they vibrate, the solid particles, they vibrate at their positions, at their fixed positions. So you need to say both vibrate at fixed positions. Now, the fourth point that you sometimes are required in some of the questions is to talk about the compressibility. Now, obviously, the distance between the solid particles or molecules is not there. There's no distance, so you cannot push them further closer. So they are incompressible. Now, what I want to specify here, that some of the students assume that the liquids are compressible. The liquids are also not compressible because the distance between the particles of the liquid is also negligible. So as compared to the gases, as you can see, the gas particles are further apart, so they can be compressed, but the liquid and solids cannot be compressed. So here is the details. You can pause and go through it. So one of the major difference is about the positions, the distance between the particles, and then the force of attraction. Now the next topic is density. Considering the space between the solid particles, you can see that the solid particles would have maximum density. So density is how closely the particles of a matter are kept. So if the particles are very close to each other, they have high density. As compared to gases, the gases would have a very low density. So density, mathematically, it is defined as mass divided by volume. And you need to remember this equation. It's not there in your equation sheet. Now density is, what is the meaning? It is how much mass is contained in a given volume. Now, as with any other physical quantity, you need to know the unit. The density is measured in kg per meter cube, or sometimes if the mass is given in grams and volume in centimeter cube, you can also calculate density in grams per centimeter cube. But be careful when you're calculating what is the unit they have given you in the question. If the unit is grams per centimeter cube, you don't need to convert it. But if the unit is kg per meter cube, you need to convert grams into kg, because kg is the standard unit for mass. And you need to convert centimeter cube to meter cube by dividing by 6 zeros, because 1 meter, 1 centimeter is 1 over 100 meters. So if you do cube both sides, so this one would be cubed 2. Okay, now what you need to know apart from this equation for density is the practicals, the measuring density for 3 types of things. One is liquid, another is irregular solid, the solid whose sides you cannot measure using a ruler, and the other one is regular solid, the one which is like a perfect cube or a perfect square whose sides you can measure with a ruler. Now for all the three, one statement would be same: mass is measured using a balance. So you've measured the mass. So once you have the mass, how do you measure the density? Remember, density is mass divided by volume. Now the symbol for density, if you see this symbol is called as rho. It's a Greek alphabet, so don't get very much confused. In physics we use a lot of Greek alphabets because apparently English alphabets We need more of them. So we use both English as well as Greek alphabets. So this is defined as mass over volume. So we got the mass for all the three, whichever comes in your exam. So you got the mass using balance. Make sure that you write measured. It's not calculated. And what are you measuring it? You're measuring it with the balance. And then you divide it with the volume. Now, how do you measure the volume? The volume for the liquid would be measured. So you take a container, pour whatever liquid you are taking. It's a measuring cylinder. So whatever it reads, 10 ml or 20 ml. So you put the liquid in a measuring cylinder, the reading would give you the volume. For the irregular solid, take a measuring cylinder. There is, and add some water. Let's say the initial volume is 10 ml. And then when you pour your irregular solid in it, obviously the volume is going to rise, isn't it? You put some solid in the liquid. Let's say this is your irregular solid, which you've put in the liquid. The volume rises to, let's say, 15 ml. So what's the volume of the irregular solid? Is 5 ml. Because 10 ml was the original volume, and when you pour in a solid, an irregular solid, whatever rise is there, that's the volume of your solid. Okay, so that's it. Now for the regular solid, you need to measure volume. So let's say you have a cube, a perfect cube. How can you find the volume? You can find the volume using length times width times height. So you calculate, so that's the keyword, you calculate volume using this formula. And how do you get length, width and height? You measure length, width and height using ruler. So again, important that you tell what device are you using to measure the given quantity. Okay, that is a wrong spelling. So all right, now so that's a little bit in detail, so you can just go through it. Now one of the exam questions, go ahead, read, pause and read, and then try to do it yourself. Once you're done, check with the mark scheme. All right, now the next topic is internal energy and changes of state. Now this topic is related to the state changes. So whenever a solid changes into a liquid, or a solid as in, let's say, a piece of ice is changing into a liquid, and then this liquid is changing into a gas. So what happens to the energy of these particles? So that is what this topic is about. Now the first thing, as you can see, the particle starts moving around when the state changes. So internal energy moving around. Which energy is responsible for moving around? Yes, you're right, kinetic energy. Now because the particle starts moving around, when would they start moving around? What makes the particle go faster? What increases their kinetic energy is the temperature. So a 10 degrees Celsius water particles will have less kinetic energy than 100 degrees Celsius water particles. Okay, if the solid is changing into liquid, the distance between the particle is also changing. So that is responsible for potential energy. So two energies, potential and kinetic. So what is kinetic energy coming from? The kinetic energy is coming from the speed, and the speed is coming from temperature. Potential energy is coming from the distance between the particles. And when does the distance comes between the particles? When would the distance between particle change? If it is at 10 degree or if it is at 100 degree, the distance between the particle is not changing. But what would change the distance is the state change. So you need to say state change. So what changes the potential energy is the state change. Okay, so let's just go back to the slide. Now, as you can see, the solid, when it melts, it becomes liquid. So at the melting point, potential energy increases. So here also, when the liquid changes to gas, potential energy increases. Solid changes to gas, potential energy increases. But when you're heating it, for example, I'm just drawing a temperature curve here. So when you're heating a piece of ice at, let's say, minus 10 degrees Celsius, it's not going to melt at minus 10. It's going to first come to 0. So the temperature is rising. When temperature rises, kinetic energy increases, and then it changes to liquid. So what happens when it changes to liquid is the temperature does not change. So ice at 0 would change into water at 0. So when it is changing from ice to water, so what is changing is potential energy. But when the temperature changes, what changes is kinetic energy. Okay, so that would be the kind of your graph. So temperature would increase. Whenever the temperature increases, the kinetic energy would increase. Now, specific heat capacity. Now, if you're giving energy to a glass of water or a glass of oil, which is quicker to heat? I'm telling you from experience, when I'm trying to put water in a pan, or not in a pan, on a saucepan to heat some water to make a coffee, or if I want to heat oil to cook some food, oil heats up quicker even if they have the same mass. So what's happening? Why oil heats up quicker than water? The quantity that's responsible is specific heat capacity. Say, what does a specific heat capacity of water is? As you can see, there are some values on the screen. I'll take a minute and read those values. Go ahead and pause the video and read those values. So the specific heat capacity of water is 4200 joules. So as you can see, the water has the highest specific heat capacity. That means it would take highest amount of energy to heat up. The copper has minimum specific heat capacity, so it would take the minimum amount to heat up. That's why it's a good conductor. It doesn't take much time to heat up. So it just tells you the specific heat capacity, just tells you what is the energy that is required to heat 1 gram of substance by 1 degree Celsius. Say, this is an important definition, that when you write about specific heat capacity, you write 1 kg and 1 degree Celsius. Okay, say this is all is written on the screen. Now you can pause and go through it. Let's go through a question. The temperature of the coffee decreases as the device is used. All right, the initial temperatures, we got the initial temperature as 76 degrees Celsius. Now energy, as you can see, is in kilojoules, so you need to first convert it into joules by multiplying it by 1000. So whenever you see the word K except kilogram, times it by 1000. Now the density of the coffee is given and volume is given and the specific heat capacity is given. Now they're asking final temperature. Okay, so whenever the temperature change is required, we always use energy equals mass times specific heat capacity times this triangle represents change, and theta, this theta is a symbol which you might have used in math. This just shows temperature change, so this is temperature change. Now energy is 15,000, but we don't know mass, but they've given you volume and density. So what can we do? Mass. So first we'll calculate mass is, times. So mass is equal to density times volume. So then we use the values, calculate the mass, and then we have specific heat capacity here, 4200. So you divide, so I'm going to just write here, and let me just take an eraser. Okay, so I'm just going to do this. So done that. Now we got the temperature change as 17.088 and the initial temperature was 76 degrees Celsius. So what do we do then? We calculate the final temperature by taking 17.088 from 76, that is 59 degrees Celsius. So 58.9, whatever your calculator is giving you. Okay, now the next topic that I want to talk about is the latent heat capacity. So the latent heat capacity is the energy that is required to change the state of 1 kg. Heat capacity was 1 kg, 1 degree Celsius. This is just 1 kg because you're changing the state, you're not changing the temperature. So always understand, do not get confused between latent heat and heat capacity. This is for state change of how many kgs, 1 kg only, okay, of 1 kg. Now this equation is given in the exams in your equation sheet, so this is where I've written it. So this equation, energy equals to mass times latent heat. L is for the latent heat. Unit is joules per kg because energy should be in joules and mass should be in kg. So whenever you are changing from solid to liquid or from liquid to gas, it is called latent heat. You don't need to remember these numbers. I've just written it just to tell you that if you're changing, if your ice is melting, this is how much energy is taking. 1 kg of ice to melt at 0 degrees Celsius would require 334,000 joules. Okay, now for your exams. Now temperature change, when does it happen? Only in specific heat capacity. Latent heat, it remains same. Energy goes in specific heat capacity to increase the kinetic energy because the temperature is changing, speed increases. Latent heat, potential energy increases because the bonds break. And the equation is this. Now pressure. If the gases are particles which are moving around with a huge speed, they would end up colliding with each other. Okay, and collision produces forces. Okay, now here you go. So what causes gaseous pressure? Gas particles, they move randomly and rapidly and they collide. Because of the collision with the walls of container, it produces force. Okay, some of you who are doing higher, just remember that force, this is not only higher, you must have done second law. The second law is force equals to change in momentum, Newton's second law, divided by time. So when a gas particle is colliding, its momentum is changing, and that change of momentum produces force. You don't need to write that, you just need to write that due to the collision it exerts forces, and then pressure is force divided by area, hence gases have pressure. Collision, forces, pressure. As you increase the temperature, if you heat up a gas, what would happen? Its speed would increase, they will have more kinetic energy, and because it has more kinetic energy, it will move faster, more collision, more forces, and hence more pressure. Now go ahead, pause and try to do this exam question. So temperature increases because, okay, you go ahead, pause and do it. If you've done, that's your mark scheme. All right, pause and check. Now if these are the equations we have done so far, you have them in your equation sheet. A quick fire quiz, pause and do it yourself and check. And then this is for triple. The pressure in gases, you must know that the pressure is because of the collision produces forces, and then the pressure. Now apart from that, you're also required to know this equation. Pressure times volume is constant. Okay, let me just try and make one diagram. Okay, so if, let's say you have a gas in a container. Okay, this container is a cylinder, and what you can see here, this is a cap where we're trying to entrap these circles. These are gas particles here. So they are gas particles which are trapped here. Okay, now the gas particles are colliding and they have some pressure. Let's call that pressure as P1. Okay, the first pressure. And the container has some volume. Now, if the gas temperature is not allowed to change and you try to push this cap inside so that you have decreased the volume, can you see the volume has decreased, and let's say the new volume has now become V2. So you have applied a force, and because of that force there has been some displacement, so you've done a work. So what has happened to that work is, so work is force times distance. So because of this applied force and this distance moved, there has been there is a work done. So because of that work done, the pressure now increases to, let's say, P2. So what you need to know for your exams in GCSE is